Hey, welcome back. Next, we'll implement get on a doubly linked list. So get takes an index, a number, and it returns the node at that index, at that position. And we could implement it the same way that we did with our singly linked list, but there's actually a nice optimization. It's a pretty significant change that we can make that we can only do with a doubly linked list. But just to recap or recall how we did it with a singly linked list, let's say we're looking for .get and we pass in 5, or let's say 6. So we're looking for the item at index of 6. We started at the head, that's our only option, and then we had a counter variable. We set it equal to 0. This is index 0. And then we just did, in a loop, .next, we add 1 to counter. It's now 1. .next, counter is 2. .next, counter is 3, 4, 5. .next, counter is now 6. So we return this node, 95. And that works. And if we wanted to do, I don't know, index of 8, for example, we still have to start at the beginning and just go all the way down. Now, if we have 1,000 items in the list and we're looking for the second to last item in a singly linked list, we have to go through all the items before it. In a doubly linked list, we could do the same thing. We could start at the beginning and work down to the tail or to the element, but we could also start at the end and do .previous, .previous, .previous. So you could just do working from the end if you wanted to, or you could only work from the beginning. But the optimal solution is to work from one or the other depending on the index that is provided. So if I did, let's make a new list that's a little larger. I think 10 is the largest I can do. If this is the list, we know that there's 10 items in here. The highest index is 9. If somebody is looking for the index of 7, if someone did this list .get 7, we could just start at the beginning and just add until we get to index of 7. But 7 is closer to the end of the list. So we could, and we should, start at the end and work backwards. So we know this is index of 9. It's the highest index is 1 less than the length. So we can start at 9 and work back to 8, back to 7. So that's what we're going to do. We're going to write code that checks, is the index that's provided closer to 0 or closer to the last index, the length minus 1. And that would make a very significant difference if we're talking about, I don't know, 1 million items in a list and we're looking for the 900,000th item, for example. No need to start at the very beginning. So here's the pseudocode. The first thing we need to do is just check if it's a valid index. So if it's negative or greater or equal to the length, return null. Remember, it can't be equal to the length. If there's 10 items, there's nothing at index 10. The highest is 9. Otherwise, we're now going to check if the index is less than or equal to half the length of the list. If that's the case, we're going to start from the beginning and move to the right, .next, until we find the correct node. Otherwise, that means that the index is greater than the half of the length of the list, meaning that it's closer to the right side or closer to the tail. So we'll start here, and instead of adding 1 each time we do a .next, we will subtract 1 from a counter every time we do a .previous. So our counter is going to start as the last index. Our position will be, in this case, 9, because there's 10 items. 10 minus 1 gives us 9. Or if we had 5 items in the list, we would start at index 4 and subtract 1 each time we did .previous. So hopefully this makes sense, this idea. All you have to do, take the length, divide by 2, and compare the index to that result. And it's up to you. If we're looking for the exact middle of the list, the middle index, if you would rather group that in with the head or with the tail. Doesn't matter. Okay, so give that a shot. One more time, here's the pseudocode. Oh, return the node once it's found. I didn't specify that. And that's pretty much it. So try it out. In the next video, I'll have a solution.